Hello and welcome to my presentation on the practical applications of team tactical formation and player position identification in association football. My name is Hadi Sutude. I recently completed my PhD in soccer analytics at ETH Zurich, working on identification of team formations and player positions. I was also a teaching assistant for the university soccer analytics course. And before starting my PhD, I worked with the Dutch Football Association as a football data science consultant. I'm also pretty active on LinkedIn with more than 39,000 followers sharing football data content on a regular basis, and have experience in several football data hackathons organized by clubs and football associations. Here is just one example from 7 years ago when I was in Paris for the Paris Saint-Germain's competition. Probably if you have in front of him and three players on the front line. These formations are also important for the coaches. For example, here you see Bielsa talking about how formations should counter each other. He thinks if an opponent is playing a 4-3-3, his team needs to play in a 4-2-1-3 formation. And that's how, for each midfielder player from the opponent, there will be one player from his team to do the man marking. We have also seen that when coaches need to get their qualification for coaching, they in some cases need to write a thesis and they choose a topic related to formations. In this case, Stefano Pioli doing his thesis for the Italian FA, choosing lateral chains in 4-4-2. The formation choice also has physical load implications. A recent survey has shown that basically players who are playing in a back three show more high intensity and physical load compared to the players who are playing in a back four. For this presentation, I want to focus on a second paper of my PhD thesis, shape graphs and the instantaneous inference of tactical positions in soccer, where the objective was to use tracking data to infer positions and later on formations of a football team. The idea starts with each frame of the tracking data where you focus on one team, mainly the outfield players. In this case, you have 10 dots or 10 players playing from bottom to top. And we use basically a space division, a pitch control model, in this case, a Voronoi diagram, to divide the areas that each player is controlling or can arrive earlier than the teammates, assuming they have equal speed. So we will end up with these cells. And if we connect all the players who are neighbors of each other, we end up with the graph representation shown on the right side, which is known as Delaunay triangulation. It contains a lot of triangles. It has the nearest neighbors of the players connected to each other, the convex hull of the team, and also it's probably something similar to what we see on TV when coaches show up and talk about the arrangement of the players and that they need to create triangles. This representation also means that we don't need to apply any normalization or scaling, because no matter where on the pitch or how compact or narrow the structure is, the edges would remain the same. But one issue with this Delaunay triangulation is that it is sensitive to small player location changes. Here you can see two cases where there are four players, which we argue that they have the same, let's say, arrangement, but only moving player P a bit up and down, it results in adding and flipping the, let's say, diagonal edge. And that's a noise that is added to our, let's say, representation that we want to avoid. So to stabilize this Delaunay triangulation, we are going to, let's say, compute the stability of each edge, where the stability of edge PQ is equal to 180 degrees minus the sum of the opposite angles facing that edge. So if we apply this stability definition of in each edge, we end up with these values that you can see on the initial Delaunay triangulation of one team. We pick a threshold 45 degrees and start with the edges that are below this threshold, starting with the minimum one, which is 10.9. We remove this edge, update the stability values of all the edges on the newly, let's say, merged face, pick the next minimum, which is 11.3. We have two edges with that value, remove them, keep doing the updating until there is no edge remaining with the stability below this threshold. So this is a subgraph of the initial Delaunay triangulation, which we call shape graph, and it's more stable, and we are going to use it to later on infer positions and formations of the team. We are going to start with first inferring the positions, where you have the shape graph for each frame of the match for each team, and we have 25 tactical position possibilities for each player. Ideally, we want to be able to say this player who has been highlighted, he is a left midfielder because he is to the left of this graph in a horizontal manner, and vertically he is in the middle. So we are going to decompose the graph on two levels, vertical and horizontal. For the vertical level, we pick the shape graph we had, we use the face centers as references. Players who are above the maximum face center vertically are colored dark red, which means these players are on the front line. Players who are below the minimum face center are colored dark blue, which means these players are on the back line. We remove these colored, let's say, nodes, and then construct a shape graph on the remaining players and introduce three more levels: dark, light blue, gray, light red. Basically, we have 5 levels maximum for the vertical level, from the dark blue to dark red, which tells you whether the players are in the back line, defensive midfielder, attacking midfielder, or the front line. We also need to follow the same idea but for the horizontal level, where we pick the rightmost face center and color the players who are to the right of that dark green, which means these players are on the right channel. Players who are to the left of the leftmost face center are colored dark brown. These are the players to the left. We remove them, construct a shape graph on the remaining players, and introduce up to 3 more levels. So in the end, we have 5 colors for the horizontal level, from the dark brown to dark green, left, left central, central, right central, and right channel. So each player is assigned 2 colors for each frame, and these 2 colors, the vertical colors and horizontal colors, translate to the momentary tactical position. For example, a player who has been colored dark blue in the upper half semicircle and light green in the lower half semicircle, based on this 5x5 matrix, is the right center back, dark blue, light green. So we have these 2 colors per player per frame. What we can do, we can pick a player, for example, number 19, and just do the visualization of the vertical colors and horizontal colors we see for him over the whole match time. As you can see, number 19 is mainly playing in the back line because of the dark blue, and also the light brown tells us he is in the left central channel. So dark blue, left central channel for the light brown, he is the left center back. You can see there is a gap in this time series. This is the moment that the team is making the substitution, and you can compare before and after that to see this player is still playing as a left center back. Then there is a second gap. This is the moment that number 13 is coming to replace number 19. And it's obvious that number 13 is operating in a different position because of the light blue color and also the gray color or light brown color we can see for him. That translates to a defensive midfielder who is central defensive midfielder and also left defensive midfielder. So he is switching between these 2 channels horizontally. And then it comes to the final gap. This is another substitution for the team. And after that, you can see that number 13 is mainly moving to the CDM position, central defensive midfielder position. We can pick the same player, number 19, that we have seen before. And as we said, we have 25 positions for each frame that this player can be assigned to one of them. So if we just go over the whole match, the time series we saw, and just compute what percentage of the match time we have observed him to be in any of these cells, we see this number 19 appeared around 56% of the time in the left center back position, 26% of the time in the center back position, and around 9% of the time in the left back position. So this is how we can profile this player with this 5x5 grid occupancy matrix, which we call this visualization position map. For the case study, we are going to focus on South Korea's match against Portugal from the World Cup 2022. And in case you don't remember that match, I'm just going to play only a short highlight so we can better remember what happened in that match. Portugal. Okay, so this is the match probably some of you recall. And if we go back to the lineup formation we saw in the beginning of the presentation, it was 4-1-2-3-4 South Korea. But the point is that this is just a prediction before the kickoff. And depending on the source you choose, you may end up with a different formation. For example, you see SofaScore having the same, maybe similar formation, but they call it 4-3-3, where there are 3 players in midfield in a flat layout. Or if you pick Football, another famous football app, you can see they have a different formation for South Korea, 4-2-3-1, where basically the team is playing for 2 double pivots. Now the question is that what was the formation for South Korea, given that depending on the source it can be different, and we want to use tracking data to infer that. So we are going to use the tracking data from the World Cup TV broadcast, 30 frames per second. And if we just want to see how that tracking data has been generated, is basically using the TV footage, as you can see here, or a tactical camera, and applying machine learning and computer vision to detect and track the players and convert that to the coordinates. We will be able to, let's say, apply the shape graph that we saw before, and then do the coloring and infer the positions of the players in each position. So this is how the final, let's say, output looks like. You have South Korea playing from bottom to top, and this is how the shape graph looks like for them, and also how the coloring, where each player has been assigned 2 colors, basically is visualized. If you are interested in the full animation of this match, you can head over to my YouTube and find the full animation there. So what was the formation for South Korea? We saw that FIFA says 4-1-2-3. What we can do, we can just use the position maps that we have, let's say, created to arrange them according to that layout. And this is the visualization we end up. The players in the back line, the one single defensive midfielder who is playing a bit, let's say, defensive and more deeper than the other 2 players, and then the front 3. And this can be, let's say, a good visualization to see where we have the deviation between what FIFA, for example, as a data provider is suggesting and what we have seen based on the tracking data. Probably we can argue that for the backline players, it's doing very well. For the players on the midfield, that's also what we see, like number 5 spend around 26% or 7% in the central defensive midfield position, but also around 8% in the center back position, so he was dropping to the back line. Number 9 spending around 45% as a center forward position, so that's also a good, let's say, place to put him. But when it comes to number 7 and number 10, you can see their position map shows a really high probability across a lot of cells. And this can be an indication that these players have switched positions during the match time. And that's why we have ended up with these, let's say, high probability maps. So how can we learn more about South Korea? We can just stack all the time series visualizations we saw for one individual player and end up with this visualization for each starting player on the left. We have the possible substitution on the right. We have the moments that the goals have been scored, highlighted with these vertical bars. We have the moment that we had the halftime and the moments that we had the substitutions where the gap and inside the gap having a dot means that that's the moment that, for example, number 11 came in to replace number 10. The moments that the opponent made the substitutions are also marked with these, let's say, substitution symbols on top of the plot. For your reference, I have the 5x5 matrix on the top left with the colors for the vertical and horizontal level. And we want to see what we can learn from South Korea. So looking to the players number 15, number 20, number 19, and number 3, the dark blue color we can see on the vertical level tells us that these players were the backline players, where number 15 was the right back because of the dark blue in combination with dark green. Number 20 was the right center back because of dark blue in combination with light green. Number 19 was the left center back because of dark blue in combination with light brown. And 3 was the left back because of the dark blue in combination with dark brown. As you can see, the left back and right back are also playing a lot in offense because it's not really mainly dark blue. Sometimes they go to the gray channel, sometimes they go to the light red and red channels. Number 5 is the single defensive midfielder because as you can see, the light blue color that you have mainly and also the gray color in the horizontal level. 6 and 18 are the two midfielders in front of the single defensive midfielder. 6 is playing to the right and 18 is playing to the left. 10 is the right winger, at least in the beginning of the match, dark red and dark green. And 7 is the left winger, at least in the beginning of the match because of the red color and dark brown color. And 9, as you can see, mainly red on the front line and in the center, so center forward. What is interesting to observe is that this is the moment that Portugal scores the first goal. You probably see after the first goal has been scored, number 3 is moving more to play in offense, and the same for number 15. So maybe that's a reaction for the fullbacks to play more advanced. And you can see this is the moment that South Korea scores the equalizer. And if you pay attention to some moments before the equalizer, number 18 and number 6 have changed and switched their position. So 6 has moved from the right to the left because of the change of color from light green to light brown. And the same for number 18 from light brown to red, light green and green. And you can also see this is also the moment after the equalizer that the wingers number 10 and 7 are also switching a lot their sides because of the change of colors in the horizontal level. Then you have the halftime break, and after the halftime, it is interesting to see that number 18 and 6 go back to their initial, let's say, position. 18 playing as the left central defensive midfielder, and 6 to the right of him. And what else we can observe is that the first substitution for South Korea, they bring number 11 to replace for number 10. And based on the positions we see, number 11 is just bringing a fresh leg. So it's just replacing a left winger with another left winger. And going back to the halftime, you can see that in the beginning of the second half, number 7, who was the left winger in the beginning of the match, has moved to the right. So that's also a position switch that resulted in those high probability matrices we saw before. The second round of the substitution, you can see this is when number 16 is replacing number 18. So they are taking out one of their, let's say, midfielders and bringing a striker. So it's 1-1, and South Korea brings a striker on the pitch. And this is exactly the moment we can see that they make another substitution where number 13 is coming in and replacing number 19. So basically, they took one defender out, one left center back out, bring in a player in the, let's say, defensive midfield position. So switching from one single defensive midfielder to two, and also checking out one of the attacking midfielders and bringing in a striker. So this is the moment we can say that South Korea has changed the position from the 4-3-3 to 4-2-4. And then it comes to the last substitution of the match, where after they have scored the goal, the winning goal, they are bringing a defender. So number 24 comes in to replace number 9. So this is the moment you may argue that South Korea has moved to a back five, 5-2-3. They want to keep the win for the few minutes that is remaining from the match. And that's how you can basically learn how South Korea started the match, whether the wingers made switches and which formations they changed to, in this case 4-2-4 and 5-2-3, and how they reacted to the goals and the substitutions. We can also profile the players based on the 5x5 matrices. Here we have, for example, one case where you can see how the players' position behavior changes in position and out of position. So here, clearly, based on the in-play time, he was the left back, but you can see in position he was going more in front than out of position, which is something that probably we expect from a left back. Another example belongs to this player here we have, where in position he is playing more higher on the pitch to the left, so he clearly was a left winger, also moving inwards, but out of position he was dropping more to the, let's say, deeper channels. I want to highlight that what we presented here was mainly descriptive. Probably this is a good example to see that maybe some coaches are interested in prediction of formation, what is the best formation to play against another formation, but we are just describing what has happened in the past match or past 5 matches based on the tracking data. You may pick a signal based on what you have seen so far, and it's the decision of the coach to decide what formation to play against a team. And that's not what we have, let's say, covered in this presentation. I want to also highlight another application in which is fan engagement. Given that the widespread access to TV broadcast, a lot of companies are providing TV broadcast tracking data. Given a quality footage exists, you can pick a match, for example, from more than 2 decades ago where South Korea played Portugal and try to understand what formation and positions the legendary players played in that match, and that can be something interesting to engage the fans with. If you're interested more about this topic, you can read my PhD thesis, which is publicly available on the internet. And to summarize, we started with the shape graphs and used colors to basically infer the vertical and horizontal alignment of the players and the positions of the players in each frame. and then infer the formations when with the overall setup, with the position maps and also the time series view for the dynamic, let's say, representation. In the end, we looked into how we can do the profiling of the players, mainly for the scouting in position and out of position. And thanks for your attention.